All right, so today we're going to look at some different types of matrices that can be used to do different things. So first of all, we're looking at, if you get told you've got a binary matrix has only ones and zeros. So you can see in these matrices examples here, you can only see ones and zeros. So that's what binary matrices are, and that's used a lot in the, I believe, in the computer coding. They use binary, ones and zeros, to program their stuff. So there's binary matrices, and then what we have is we have a particular type of binary matrix, which is a permutation matrix. So a permutation is a square binary matrix. So what does square mean again? We've got the same rows and columns, good. But also a permutation matrix only has one in each row and column. So if you have a look at here, see how there's only one in row 2 and also in column 1. So you can see it doesn't necessarily, it will be on a diagonal, but doesn't necessarily need to be. So this one here, you can see there's only one in each of the rows and each of the columns. So a permutation matrix can be used to rearrange elements in another matrix. So you've seen, we've been doing the multiplication, and that's this manual method. If you know how it's worked out, it can make you quicker. So if you look here in this example, they've said matrix X is this matrix, which is actually a 3 by 1, and they've given you a permutation, which they've called P, and it's a 3 by 3. So what they're going to do is they're going to see how they're multiplying matrix P here by matrix X, which is a 3 by 1. So it's defined because you can see that those two are equal, and we end up with a 3 by 1, which is this answer here. So what you're going to notice, if you get a permutation, so there's only one on one of the rows. So if I was multiplying this, I would go run and dive. So it'd be 0 times t, which is 0, plus 0 times a, which is 0, plus 1 times r. So see how I said 0 times t plus 0 times a plus 1 times r. So that means the r showed. So see how it was in the third spot, and the third one down ends up showing. So if we do this next one and we go this row round down, see how the 1 is in the middle, so the middle letter shows up. So on this last one, what we're doing the last bit, we're going to see this row, the last row by this column, see the 1's in the first spot, so the T showed. So we now have that permutation, swapped those letters around. Didn't change them, just swapped the order around. So that's what a permutation is. So if you see how they've squared it in this next example here, that will flick the letters around again, and you can see it actually flicked them back to the start method. So we could say we could use a permutation twice and go back to the way they were at the start. All right, so just so let's have a look at these examples. So it says up here the matrix product, so we can see this is actually a permutation matrix because you can see there's only one row, one in each row. Okay, and they're saying you're multiplying it by that other matrix, that column matrix that has letters. So you can see, you could type it into your calculator, that whole thing, and it will rearrange it for you. But I'm going to be much quicker knowing how it works, because all I'm going to do is I go, all right, when I go across the first row and down, can you see that the 1 happens on the fourth one? So 1, 2, 3, 4. The fourth letter down is P, so that will be the next one. So if I go the second row, do this second row here, and I go down there, So can you see the 1 is on the third? So what's the third letter? A, good. So A will show, so we'll have A. Okay, then if we go again, this we're going across this row and down, the 1 is in the first spot, so what letter's going to show?
Probably L.
Yep, beautiful. If we do the next one, we go across and we go down. The 1 is in the second spot, so what's the second letter?
E.
E. And then our last one, if we do that,
S.
it's the 1's in the last spot, so S. Good. So where's that answer?
D.
D. Beautiful. Okay, this one, it says matrix P is a 4x4 permutation matrix, and matrix W is another matrix such that the matrix P times W. So here I've written that out. They're going to do P times W, and I've created a 4x4, which I don't know but they did say P is a permutation, so I know it'll be 1s and 0s. Now, this matrix product, so when you times these two together, it's going to swap around the first and the third row. So I just made this W up, just so you know, this W, like those numbers, I made them up, okay? So they were a made up scenario there. And I did that because it's telling me it wants the answer when it wants the first and the third row to be swapped around. So for me, that means I'd have a 3 up the top. I could have used letters, I just chose numbers. I want a 3 up the top and the 1 there. So if you're going across, so if you think about, we're going to go run across here and down there, the first row, and it's going to give us that number. So where do I want the 1 to be? In the third spot, because that's where I want that one to show first, and I'd put 0s everywhere else. So in the second row, I want 2 to show because I don't want to move that. So where will the 1 be? It'll be in the second spot. And now I want the number 1 to show. See how 1's in the third spot? So I need a 1 here, don't I? Because that's the first one. 0, 0, 0. And the last one, I don't want 4, so 0, 0, 0, I want the 4 to show like that. Okay, so which one is this permutation?
B.
B. Done.